There are well over 1,000 nuclides, and among them are a large number of gamma ray emitters. As gamma emission always occurs in an energy pattern characteristic for each nuclide, this gives a way of identifying radioactive nuclides and of determining the composition of isotope mixtures. Analyses of this type are made with a gamma spectrometer. The composition of a radioactive specimen is to be determined. The scintillation detector converts the emitted gamma energy spectrum into a spectrum of electrical pulses. The pulse spectrum thus obtained is then analyzed in the spectrometer. Energy levels are successively scanned. The count rate found on each energy level is plotted on a graph, resulting in a characteristic pattern of the isotope under investigation. The spectrometer is composed of standard modules of the Phillips range of functional units for the measurement of radiation. An ultra-stable high-voltage supply, a logarithmic attenuator for the adjustment of the spectrometer, a power supply for the linear amplifier, a single-channel discriminator, an automatic scanner, a linear count rate meter. When the graph presenting the record of the gamma energy spectrum is completed, the equipment automatically stops scanning. The energy levels of the peaks in the spectrum directly indicate which nuclides are present in the sample under investigation. Existing handbooks contain all data on energy distribution of gamma-emitting nuclides. By determining the area of a peak, a direct measure for the quantity of a certain isotope in the sample is obtained. To explain the functioning of a single-channel spectrometer, we represent the pulses registered by the scintillation detector by straight lines. The height of each pulse depends on the energy of the gamma quantum which initiated the pulse. Each isotope is characterized by a typical energy distribution. That means that quanta are emitted only at distinct energies. Therefore, pulses of certain heights occur most frequently. Here, the measuring channel of the discriminator is represented by a slit through which we look at the pulse spectrum. Only those pulses come in for counting, the height of which corresponds with the position of the slit. To scan a spectrum, pulses are counted successively, each time tuning in, so to speak, on a certain pulse height. The numbers of pulses are plotted on a graph corresponding with the position of the channel. This is the sliding channel method of operation. The channel width remains constant during the scanning period. That means that relatively, the channel width continuously increases with decreasing channel height. The procedure has certain drawbacks when scanning spectra with a great energy span or in analyzing complex isotope mixtures. That is why the Phillips spectrometers are also equipped to operate according to a second method of scanning, the gain scanning method of operation. Gain scanning is performed by varying automatically the detector's high voltage. The channel height and channel width adjustments are kept constant. This time, scanning is performed by varying the detector's high voltage with the automatic scanner. Channel height and channel width adjustments stay fixed. Therefore, the relative channel width will be constant during the whole assay. Let's see how the spectrum is now depicted. When representing gain scanning, it is shown that an increase of the supply voltage of the detector results in a higher amplification of the pulses. The mutual relation of the pulse heights is maintained. By continuously increasing the amplification, pulses are successively brought into the channel. With this method of operation, the relative channel width does not change during the procedure. Complex spectra are presented in a more favorable way. A spectrum of radium-226 obtained by gain scanning. The spectrum of the same isotope scanned with a sliding channel. Phillips spectrometers provide means to scan gamma energy spectra either with the sliding channel or with the gain scanned method of operation, manually or automatically. Either method may be chosen to conform to the requirements for each particular sample. Gamma spectrometers provide all data for specimen analysis, to identify radioactive samples, and for the determination of the amount of radioactive material present in a sample. In short, the instrument is an excellent tool for routine analysis. By altering the number and types of functional units, Philips spectrometers are adapted to the special requirements of a specific laboratory. Various combinations are provided, including those with digital display, single or dual channel setups, those with linear or logarithmic rate meters, those with electronic or mechanical timers, those with a strip chart recorder or an XY plotter. In addition, spectrometers already in use may be easily extended or adapted to growing requirements.